Hello and welcome to another video brought to you by the Brightics AI Accelerator team at Samsung SDS, where we make training AI models fast, efficient, and pain-free. Today I want to talk to you about feature generation, also known as feature engineering. Imagine that you have a data set in the form of a table. It has several columns, each of which represents some kind of measurement that you can take in the world, either by a sensor or by asking questions or taking pictures or something of the sort, where each column is a separate source of information. Now you might ask, which ones of these columns do I need as the input to an AI model to best represent the situation? Two situations could apply. The first situation is that I have a bogus column in my database that is actually completely unnecessary for the problem I want to solve. It then becomes a matter of feature selection, choosing the right columns of the ones I have as inputs to my model. The opposite is also possible, where I could generate an additional column to my database, which somehow adds to the content of the entire database. And this is something that is usually done by what we call domain knowledge. That is, human understanding and knowledge coming from whatever field gave rise to that data set. Right? If we're talking about a data set from a kind of engineering situation, then we might need the engineer to tell us, actually, if you divide these two numbers by each other, that's a very interesting metric that we use to judge the health of the system. You have to actually rescale things. If you take a vibration, you might want to take a Fourier transform of the vibration to get you a good representation of what you actually want to see. And that is called generating an additional feature. Going through the process of discovery of what to do is the process of feature engineering. In essence, what you're doing is you're taking your data table and you're adding features at the end. These additional features, however, are not variables that you get from nature, that is, you measure them. You calculate them. Now, the traditional way of doing this is to hold discussions with domain experts to kind of suss out what knowledge they have that you should be putting into this data set by adding an additional feature with a certain formula that the domain experts give you. This is a lengthy process of a give and take, interviewing, workshopping together with people, trial and error with them to find the right features and the right way to represent these features. Feature engineering is a very, very important step in data science because of one reason. The size of the data set is usually limited. And we have therefore a certain amount of information that is stored in that data set. We cannot arbitrarily increase the amount of information in the data set. Sure, we can increase the size of the data set. We can take a point and copy it. We can take a point, add some noise to it, and copy it. That increases the size of the database, but it does not increase the amount of information about whatever situation we're trying to model. To gain more information, we have to either take more measurements of novel situations, which often is expensive or time-consuming or just not possible, or we can add domain knowledge. And the way to add domain knowledge is to do feature engineering. Now, there is one way out. If you are able to train your AI models fast enough, you might be able to do synthetic feature generation, which is that you go through a number of possibilities, possibly very large, and generate new features automatically and just try them out. Do they add sensible information to the data set that makes the training of the same AI model better? And once you've done that, you can go through a lengthy but deterministic process of generating synthetic features, trying out their various combinations and permutations, and coming up with the optimal set of original data features plus the generated synthetic features that lead to the best AI model. And we find, of course, that the accuracy and the reliability, the robustness of the AI models generated in this way are significantly better than those that are generated based on the raw original data. This obviates the necessity to go through a very lengthy discovery process by the use of brute force, by generating synthetic features and trying them all out. And this, of course, has to be enabled by fast training. Fast training is something that the Brightics AI Accelerator enables by splitting the training task across many computers and many GPUs on them, so that you can cut training tasks that took weeks down to an hour. And because it's so fast, now you can try these many possibilities and arrive at the best answer. So again, an increase in speed enables auto machine learning features that make better models. So faster training equals better models through that process. If you'd like to learn more, please contact us and give the Brightics AI Accelerator a trial. Thank you very much for listening to yet another video brought to you by the Brightics AI Accelerator team at Samsung SDS. Thank you and bye-bye.